All right, I think we're going to get this done in 2 more videos. We'll see what we can make happen. Example 11 tells us that Cody and Ginger are working independently. That's very important, guys, because if they're independent, we know something about them. Okay. Cody has a success rate of 4/5, so I'm just going to jot that down right here. That means the probability of Cody getting an answer right is 4/5. So we'll just jot that right here. Cody is 4/5. And Ginger has a success rate of 3/5. So we know the probability of Ginger. We are being asked to determine the probability that at least one of them is correct. This phrase "at least" is the important phrase there. Remember that if it's at least, that means either Cody or Ginger. It doesn't have to be both. So we're being asked to find the probability of Cody or Ginger. Now this refers back to the addition rule on our vocabulary page, and the addition rule tells me that I should be taking the probability of Cody, adding the probability of Ginger, and subtracting the probability of both. But I don't know the probability of both, so we're going to have to figure that out. That's where this independent part is so important, because if we know that they're independent, then I can figure that out, because our independent rule tells me that A times B equals both. So I can find the probability of both, and I'm shorthanding here, guys, and not writing Cody and Ginger, but that's really what that means. To find that, I will take his independent score of 4/5, and I will multiply it times her independent score of 3/5, and that gives me a 12/25 probability that they would both get the question right at the same time. So now that I know that, I can plug each of those things in here. So we would have 4/5 for Cody plus 3/5 for Ginger, and minus 12/25 for both of them. And that's removing the duplication, because we don't want to count those 12 events twice. We're counting them right now once in his score and once in her score, and so that's what we're working on, is removing that duplication. Now you can absolutely do regular addition, subtraction with fractions, find common denominators and all that good stuff. But for the sake of time, I'm going to use my calculator. So I'm going to just go ahead and enter this just the way it looks. 4/5 plus 3/5 minus 12/25. And so I find that the probability that at least one of them is going to get a question right is quite high. Our answer here is 23 out of 25. And that's equivalent, as I use my fraction decimal key, to exactly 0.92 or 92 hundredths, or 92%. That's some pretty good odds that at least one of them will be right.